The demonstration video of the node editor for OpenFOAM Case file generation developed during my summer fellowship at FOSSEE. I would like to begin by telling what OpenFOAM is. OpenFOAM is an open source software for computational fluid dynamics used widely in academia as well as industry to solve quantum mechanics problems. This project currently is built for OpenFOAM version 9, among others. One might ask why a node editor for this? Well, OpenFOAM requires case files to run the simulations which follow certain syntax, which could act as a bottleneck for non programmers or quite intimidating for beginners. A visual programming interface reduces the learning curve for the beginners as well as help professionals as well to be less error prone and intuitive designing of the case files. Project follows MVC architecture where the model is given by PyVNT or Python Venturial Node Trees library that uh, deals with node tree structure for the case generation, and the view is backed by PyQt, PyQt 6 to be precise, and controller looks after various file operations and node operations among others. I'll guide you through to how to install the node editor on your PC. You can visit this repository and either clone using this URL or download the zip folder and then extract the files and then open your Visual Studio and open that folder in your workspace. Now let open your terminal and let us uh, clone the PyVNT repository, the particular branch which I used as this one. Mm, let me first create a virtual environment to download that um, library. Let us now activate that environment. Yeah, now copy this branch name and type in this command. Sorry, let us switch to the when folder first. Let me copy this out. Mm, us install the requirements. You can use the README of the repository to follow further steps. And let us now install the requirements of the node editor as well. Good. Now let us run we see some errors. We can try to run again and the application opens up. Menu bar, and this is a side pane which contains node library consisting of all the available nodes, and properties pane which shows properties of active or selected node. We can zoom and pan using the keys, or you can find the help here in the menu bar for using the editor. Maybe look for keyboard shortcuts. And this is the scene onto which the nodes can be dragged. Each node has an input socket and an output socket. The square here essentially means that this particular node can take multiple inputs. So when I drag from an input output socket of a node to input socket of other, a connection is formed. The data flow is from left to right, ideally. I would to brief upon the various nodes available here. The node C is provided by PyVNT to create dictionary-like structures for the case file, and key C acts as the key for that dictionary. Or any of these value parameter nodes can be connected with to key C, and which will act as entries for the keys. You can give the name and other attributes as required, and I would like to tell upon less CP as well. So this value parameter node can take a node C as an input as well, but one would have to check the specs while doing so. And yeah, and like to show the output and case folder nodes are not provided by the PyVNT but by the node editor. The user can choose to leave this blank or provide with file name or a path and validate it first, and then they can either generate the file individually or choose to create a case folder and connect it to the suitable folder as per the requirement, and then generate. The this checkbox for overwriting allows the user to uh, reuse the same folder again. So if I'm creating another case file, I would just have to connect uh, to any of the files and give the same case folder name and then check on this box uh, to generate again. Yeah. You can delete a node by just right clicking on a node and selecting the delete node option. That would remove its connections as well. And the application provides a comprehensive undo and redo system, so we can just bring it back as well. But one would have to be careful about number of operations as they are limited as of now. Um, there is a provision for knife tool which can be activated using K key. One would just drag it across a connection to delete it and press key again to deactivate the mode. Yeah. And Node C and KC take multiple inputs. There is a provision to set the order of uh, their inputs as well. So I would like to demonstrate that. So if I connect both of them to a node C, I'll have to connect value parameters as well. One can choose to keep them empty. Yeah, so if I click on node C, we can see in the properties pane, or we can either right click and set element order as well and move accordingly. So I would like to bring K1 down, and now this order is set. So when I generate the file using the output node, this would show first and then this. I would like to demonstrate creating a part of block mesh text file. So every OpenFOAM case file begins with form file dictionary. Let me create that first. And let me have a root node for the file. We name this appropriately. This will act as the value for the format key. Let me add a float parameter now. This name attribute is just for convenience to identify nodes in a bigger files case file setup. Let me add vertices. You can keep on adding all the vertices. Alright. It is connect all of these keys to the root of the file. The order is as desired, so we don't need to make any changes. So let us now add the output now. That is validated, and then generate the file. So we can see our file being generated in the output folder. This looks something like this. I think I forgot to connect one of the list nodes. Yeah, the order isn't preserved. Let us see if the order is preserved. Yeah. And please save the file using keyboard shortcuts or using the file. Mm, we can choose the extension as YAML, JSON, or dot keys. And save it for using it later. Um, One can also import a pre-existing case file as well as case folder. Um, mm, just do this. See, case has loaded successfully. You can work on it further and choose to modify it. That's all. Thank you. And you can contribute to this project on GitHub.